Okay, children, assignment number 7. I'll have to repeat this. First question, IUPAC nomenclature. First IUPAC was 4-bromo 2,2-dimethyl pentane, and that was secondary alkyl halide. Second, vinyl chloride. IUPAC name is chloroethene, primary vinylic halide. And third compound I named just now, this was 3-bromo pent-2-ene. This is secondary vinylic halide. Now, second question, fill in the blanks. A is alkene. This is propene. B is HBr peroxide. Reacts and lead to the formation of primary alkyl halide, that is 1-bromo propane. This reacts with D to give E. D is aqueous NaOH. Next is 1-propanol. Then 1-propanol reacts with F to give G. You can say PCl5, and this gives, wait a minute. HBr peroxide gives primary alkyl halide. Then D is alcoholic KOH, gives propene, and propene reacts with HX to give 2-halopropane, and 2-halopropane undergoes Wood's reaction to give 2,3-dimethyl butane. A, B, C, D, E, F, G. These are the answers. Second sequence. BHC is the product. Reaction conditions A, these are chlorine in the presence of ultraviolet light. Benzene reacts with B to give chlorobenzene. This is chlorine in the presence of catalyst FeCl3 or AlCl3 in the presence of cold and dark. Nitrating mixture, and products obtained are ortho and para nitrochlorobenzene. So these two answers are ortho nitrochlorobenzene and para nitrochlorobenzene. Third sequence. A plus HBr gives 2-bromopentane. A is pent-1-ene. This is according to Markovnikov's rule. B gives 2-pentene. B is alcoholic KOH. 2-pentene with HBr gives 3-bromopentane. And last reaction is Wood's reaction. Wood's reaction will lead to the formation of product is, wait a minute. Yes. This product is this is the final product of Wood's reaction. This is 3,4-diethyl hexane. 3,4-diethyl hexane is the final product. Explain why. All the three parts, all the three questions in this category you'll find in your notes. Now coming to what happens when bromoethane is treated with aqueous potassium iodide in the presence of acetone. You have to write the balanced equation, and you'll write that Finkelstein's reaction takes place to give iodoethane. Second, propene is reacted with HCl. Addition takes place according to Markovnikov's rule to give 2-chloropropane, and the product is reacted with sodium in the presence of dry ether. Second reaction is Wood's reaction takes place to give 2,3-dimethyl butane. Distinguish between normal propyl bromide and allyl bromide. Allyl bromide has unsaturation. You'll perform the test for unsaturation. So react with bromine water, In first case, no decolorization. There's no color change in the first case because no reaction will take place. In the second case, product obtained is 1,2,3 tribromopropane and bromine water gets decolorized. This is the color change. Second, orthochlorotoluene and benzyl chloride. Benzyl chloride. In orthochlorotoluene, chlorine is directly bonded to aromatic ring, and due to this, bond between carbon and chlorine has a partial double bond character, therefore difficult to break. Whereas in the second compound, benzyl chloride, it is an alkyl halide, and bond between carbon and halogen is a single bond which is comparatively weaker. So if you react both the compounds with AgNO2, there will be no reaction in the first case, but will not write no reaction, will write something else. In the second case, product obtained will be a nitro compound. Along with that, white precipitates of AgCl will be formed. In the first case, on the right hand side, product side will write no white precipitates formed, right? First compound, no white precipitates formed. Second case, these are the products and white precipitates of AgCl are formed. How will you convert? Conversions. 1-chloropropane into 2,3-dimethyl butane. Since we have used many reactions many times, I'll not write those reagents above arrows. You will be able to understand yourself. This into propene, this is alcoholic KOH, dehydrohalogenation. Add NeHX, you'll get 2-halopropane. After that, last reaction is Wood's reaction, sodium diether. Second, aniline into orthochlorobenzene. This, in fact, you'll find in notes also. Convert aniline into diazonium salt. From diazonium, prepare chlorobenzene by using Sandmeyer reaction or Gattermann reaction. Then in the last step, react chlorobenzene with nitrating mixture. You'll get the final product, that is orthochloronitrobenzene. Then benzene into benzyl alcohol. First of all, we'll attach a side chain. For that, we'll use Friedel-Crafts alkylation. This is CH3Cl, aluminium chloride, gives toluene. Now we'll carry out a reaction in the side chain chlorination. Chlorine in the presence of sunlight, side chain chlorination will give benzyl chloride. After that, aqueous NaOH. This is NSR, will get final product. Bromoethane into acetylene. Bromoethane into acetylene. Alcoholic KOH will get a double bond. React with bromine water. This is the test for unsaturation. Product obtained will be 1,2-dibromopropane, 1,2-dibromoethane. Last reaction with alcoholic KOH or sodamide you can use. Product obtained is a triple bond, that is ethyne. Next question. Arrange 1-bromo-3-methyl-butane, compound number 1, tertiary-pentyl bromide, compound number 2, and 2-bromo-3-methyl-butane. In increasing reactivity by SN2 mechanism. SN2 mechanism is based on steric hindrance. More the steric lesser is the reactivity. Now this is primary, reactivity will be maximum. This is tertiary, reactivity will be minimum. Sorry, 2. And this is secondary, this will have an intermediate reactivity. This is the order. Next question. Out of normal pentyl chloride and tertiary pentyl chloride, which has higher boiling point and why? It's a direct question. Answer you can find in the notes also. But still, normal pentyl will have higher boiling point. The reason being, in case of the other isomer, tertiary, branching decreases surface area so that van der Waals force of attraction become weaker. Last question to be discussed. Arrange, we are given 3 compounds. Arrange 2,4,6 nitrochlorobenzene, 2,4-nitrochlorobenzene, and 2,4-dinitrochlorobenzene in the increasing reactivity by in NSR. More the electron withdrawing nitro groups, higher is the reactivity. It means 2,4,6 will have maximum reactivity, then 4-nitro will have minimum reactivity, 2,4-dinitro will have intermediate reactivity. With that, we finish the assignment.